All right, guys. Day 7 of the 100 Days of LeetCode. We're getting there. We're getting there. We're getting there. Today, we're going to be dealing with trees. We're going to be doing the binary tree pre-order traversal. It's problem number 144. It's an easy problem, but these problems introduce you sort of to the idea of trees, and they show you, how to traverse them. So today, we're going to be dealing with that, and we're actually going to start off. I'm going to take you all the way down to my iPad. So let's go. Okay, guys, so first let's just create a sort of sample binary tree that I feel is big enough to sort of convey all the concepts. So we'll start with the root, and in that root we can say have a value of 17. We'll go to the left. That has a value of 12. It'll have a right child that we can say has a value of 23. 12 will have a left child with a value of, let's say, 9, a right child of 14, and then back to 23, we can say that that has a left child of, I don't know, 18 works, right child of 27. Okay, so now we have a binary tree, and we want to traverse it using the pre-order method of traversals. So what that means is that whenever we're dealing with a tree or a subtree, we want to first visit the root of that tree or subtree, and then we visit the left node. And notice how I said tree or subtree, because now, as soon as we're visiting the left subtree, well, in that left subtree, first we visit the root of that left subtree, which in this case would be 12, and then we're going to visit essentially the root of the next left subtree, which would be 9. So we're visiting the node with the value of 9 third. And then because we're done and we have no more subtrees underneath 9, 9 has no children, now we go all the way back up and visit the right children. So 14 would be visited fourth. We go all the way back up to 17. We visit the right child of 17, of the node with 17 in it, and that would be the node with 23 in it. And now we're going to visit the left child of 23 and the right child of 23. So sometimes when you're doing these traversals, you're going to be doing something whenever you come up to the particular nodes. In this case, we're just going to be adding them to a list. So when we add them to the list, we want to make sure that the order is like this. 23, not 5, excuse me, and then 18, and then 27. So this needs to be the order that we have in the list. All right, so let's write this code. All right, guys, let's write the code. Okay, so the first thing we want to do is we want to create a list of integers because that's what we're returning. And let's just call it the list, and we can say it's a new array list of integers. Boom. And now what we're going to do is we're going to call a function that I have not defined yet. We're going to call it with root. We're going to call it with the list. And we're simply going to return the list. That's it for our pre-order traversal function. Now, we're going to create another function, which is actually going to do the traversing. And I'm just going to call that pre-order. And it's going to take a tree node, we can call it root. It's going to take a list of integers, we can call it the list. And the first thing we want to check for in here is if, null, excuse me, if the root that's getting passed in here is null, we just want to sort of terminate execution. We're just going to return, okay? Because we don't need to do anything, there's no value there, don't need to add it to the list, don't need to visit, obviously, a null node. And then if we are in a node that has a value, what we need to do is we need to add that value to the list first before we do anything else. And then, like I talked about previously on the iPad, what we want to do is we want to call the preorder function again on the left child of the root node with the list, and then again call it again on the right subchild, or sorry, the right child or the right subtree. Mixing up my words there. And that is it. We've done it. We're gonna submit it, and it should be pretty good. Oh, of course. Need a return type void. There we go. Okay. That's the solution. Thanks for watching, guys. If you like this, please like, subscribe. Today was day 7, so we got another 93 days of this. Yeah, let's keep it going.